This video will talk about factor labeling, and we'll do some practice and try to get into some more difficult problems. So first of all, let's look at this one. The diameter of a sewing needle is 0.073 centimeters. What is the diameter in micrometers? So if we use ages, first thing we want to do is consider what is the problem asking for. It is asking for micrometers. And that's that weird symbol. That's a mu in Greek. That means micrometer. Then, secondly, what is given in the problem? See up there, 0.073 centimeters. So now we need to consider what equation we would want to use. That's going to be related to the equalities and conversion factors that we're going to use. You see centimeters here and micrometers. So if we look at our metric progression, you see centi here, deci, and then the meters in this case. Meters, liters, and gram are the standard. A centimeter is 2 places away from meter, so that's 10 squared. And a micrometer, you can see, is 10 to the minus 6, but if we reverse it, it's 1 million from a meter. So it goes 10 times 10 times 10 times 1,000, so that's a million different. So for our equation, we can write 10 squared or 100 centimeters is equal to 1 meter. That's going to the standard. I always recommend you go to the standard. The micrometers, we said there's a million or 10 to the 6th micrometers in 1 meter. So now we're going to solve it. Always solve by beginning with what we're given. We're given 0.073 centimeters. And we want to change that to scientific notation just to save us time in the long run. So we need a number from 1 to 9, which means we're going to move that decimal 2 places to the right to 7.3, making the number larger. 7.3 is larger than 0.073. Then, since the number got bigger, thumbs up, the exponent must get smaller, thumbs down. So we're going to end up with 7.3 times 10 to the minus 2 centimeters. So that's where we're going to start. I've got my equalities out here, which are going to become conversion factors or fractions. So our amount given, 7.3 times 10 to the minus 2 centimeters. Let's get rid of centimeters. And you see the relationship here, centimeters to meters. So we make a conversion factor out of this equality. And notice then that centimeters will cancel and meters are left. Then we go from meters to micrometers because that's the desired unit that we want. And we take this equality and change it into a conversion factor. Meters are on the bottom and micrometer on top. Why? So meters will cancel. We have 7.3 times 10 to the minus 2 divided by 10 to the second. And again, multiply by 10 to the 6th. So when you multiply exponents, you add the superscripts. So 6 plus a minus 2 is 10 to the 4th. Then when you divide exponents, you subtract the exponents. 10 to the 4th minus 10 to the 2nd is 10 to the 2nd. So our final answer is 7.3 times 10 squared micrometers. And just as a reminder, when you're dividing exponents, you subtract the superscripts. When multiplying exponents, you add the superscripts. All right, let's up the ante a little bit, make it a little more difficult. The density of manganese, a metal, is 7.21 grams per cubic centimeter. That's density, mass over volume. What is the density of manganese expressed in units of kilograms per meters cubed? Ooh, that sounds really scary. So let's kiss it. Keep it simple, keep in step. Step 1, what is the problem asking for? That's not a problem, I see that. I'm looking for kilograms per meters cubed. I can handle that. Gaining some confidence here. G, right, in ages. What is given? 7.21 grams per cubic centimeter. Again, not a problem. Now we've got to deal with the units. We've got kilograms and grams. We got meters cubed and centimeters cubed. Grams is one of our standards. And kilo is 1,000 grams. So you see the relationship there. 3 units of 10 apart, 10 to the 3rd. If we consider centi again, there are 100 centimeters in a meter, or 10 squared centimeters in a meter. So those are where we're going to begin. Our equations are going to involve the equalities that we just looked at. So the first equality we saw was 1,000 grams, or 10 cubed grams, is 1 kilogram. The other equality was 100 centimeters, or 10 squared centimeters, is 1 meter. But notice the unit is not centimeters, it's centimeters cubed. It's not meters, it's meters cubed. Therefore, we need to cube this relationship. Cube it, which means 10 squared centimeters times 10 squared centimeters times 10 squared centimeters. That would give you 10 to the 6th. Why? Because you add the superscripts. 10 to the 6th centimeters cubed is 1 meter cubed. So then we're ready to solve this, which means we begin with the amount given. Go back to the 7.21 grams per cubic centimeter. It's really important that you remember to go one step at a time. Keep it simple, keep in step. We're going to tackle one unit at a time. We're going to do grams to kilograms first. Then we'll do cubic centimeters to cubic meters. Don't even think about cubic centimeters, and then you won't be bothered. We know how to go from grams to kilograms. We're going to start with our equalities up here so we have them handy. The relationship between grams and kilograms, we can take that equality and turn it into a conversion factor. Notice grams goes on the bottom, so they cancel out, and we're left with kilogram. The next step is we need to get rid of the cubic centimeters. That relationship is up here, cubic centimeters, meters cubed. Turn this equality into a conversion factor fraction. Notice centimeters cubed is on top here. So the centimeters cubed cancel, and you're left with cubic meters on the bottom. And then you look at our exponents, 10 to the 6th divided by 10 to the 3rd. You're dividing, so subtract the superscript, 6 minus 3. And we end up with 7.2 times 10 to the 3rd kilograms per meter cubed. Okay, let's try one more problem. This time we want to convert 1,453 grams per cubic centimeter to kilograms per liter. So again, we use ages. What is the question asking for? It's asking for kilograms per liter. What are we given? We're given 1,453 grams per cubic centimeter. Right, then our equalities will become our equation again. We need an equality between grams and kilograms. We need centimeters cubed and liters. There's a relationship there. And it looks pretty scary, so let's break it down step by step. The KISS method is not just keep it simple, it's also keep in step. One equality is going to relate to grams and kilograms, which we looked at before, but we'll look at it again quickly. Grams, deca, hecto, kilo. That's 1,000. 10 times 10 times 10. So there's 1,000 grams in a kilogram. 10 cubed grams in 1 kilogram. Now the other one's much trickier, but we can see centimeters cubed here. Centimeters cubed is the volume of a regularly shaped solid, length times width times height, and it is equal to a milliliter. Now there's a relationship between milliliter and liters. Milli, centi, deci, liter. So there's 1,000 milliliters in 1 liter. We write our equality 1,000 milliliters or 10 cubed milliliters is 1 liter. So now we're ready to solve the problem. And we always begin with what we're given, 1,453 grams per cubic centimeter. We're going to use those equalities and conversion factors to cancel the undesired units and leave the desired units. So let's start one step at a time. Remember, we're not going to try to do both units at the same time. That's too scary. First step, let's take grams and change it to kilograms. We already saw the equality. 1 kilogram was 1,000 grams, so we can make this conversion factor fraction with grams in the denominator there. Why? So grams cancel. Gram divided by gram. Next, let's deal with cubic centimeters. We already said that cubic centimeters is equal to 1 milliliter. So if you want to write it out, you can do a conversion factor like this. Cubic centimeter divided by milliliter. This is in the denominator here, numerator here, so cubic centimeters cancel. The relationship between milliliters and liters, there are 1,000 milliliters in 1 liter. Since milliliter is in the denominator here, we put it in the numerator here, so milliliters cancel. And then we need to deal with our exponents. 10 to the 3rd divided by 10 to the 3rd. See, that's in the denominator, so that cancels. And we're left with 1,453 kilograms per liter. We just need to change that to scientific notation. Turn our number into a number from 1 to 9, 1.453. Since the number decreases, the exponent has to increase. We move the decimal 3 places to get to 1.4, so we have to increase the exponent 3 places, and we get 1.453 times 10 to the 3rd kilograms per liter. And you'll notice the thumbs up, thumbs down rule.